What's up guys, this is Engineer Jack and this is Hydraulics. So una, pag-usapan na muna natin yung course objectives for this subject. Number 1, we should develop a good understanding of the principles of water behavior under the influence of forces. Number 2, understand the principles involving physical ideas as well as mathematical ones and includes derivations and analysis of resulting equations which describe water behavior. And number 3, develop skills in solving practical problems which involve numerical calculations from working formulas used for hydraulic analysis design. Let us first define fluid mechanics or hydraulics. Fluid mechanics is one of the branch of engineering mechanics. Kasi yung engineering mechanics natin, meron tayong tatlong branches. So una, na branch of engineering mechanics, we have the mechanics of rigid bodies. And the mechanics of rigid bodies is divided into two. Meron tayong statics of rigid bodies and dynamics of rigid bodies. Dito sa statics of rigid bodies, dito natin inaaral yung action of forces in a particle na rigid. Ibig sabihin ng rigid, undeformable, hindi nagde-deform. Tapos, ano ba yung behavior ng particle na yon under the action of forces? If it remains at rest, ibig sabihin that is statics. Pero kung meron namang motion or acceleration in our particle, doon naman natin yan maaaralin sa dynamics of rigid bodies. Another branch of engineering mechanics, we have the mechanics of deformable bodies, or ito yung tinatawag na strength of materials. And last branch of engineering mechanics is the mechanics of fluids. Another definition of fluid mechanics or hydraulics, it is the study of fluids at rest or in motion. Inaaral natin dito yung behavior ng fluid at rest man or in motion. Ibig sabihin ng fluid at rest, ito yung fluid statics. Yung fluid in motion naman, ito naman yung tinatawag na fluid dynamics or ito talaga yung tinatawag na hydraulics. Kasi sa old curriculum, sa civil engineering, meron tayong fluids 1 and fluids 2. So itong fluids statics, ito yung tinatawag na fluids 1 sa old curriculum, and yung fluid dynamics, ito naman yung tinatawag na fluids 2. So yung fluids, basically, meron tayong 3 phases lang yan. It can be a liquid, it can be a gas, or it can be a plasma. Pero syempre, sa civil engineering, yung aaralin lang natin or gagamitin natin na fluid is yung liquid only and the gas. Kasi yung plasma is part of our body and syempre hindi natin yan cover dito sa civil engineering. So more on liquid and gas lang tayo. So, ang fluid mechanics din has been applied in such areas like designing the canals. So, paano ba natin madidesign yung canal natin using fluid mechanics? Mga ganun. Pwede din sa dams, kasi sa dams, before tayo mag-design ng dam, alamin muna natin dapat na ang behavior ng water or yung liquid natin sa dam. So, ano bang binibigay niyang pressure? So, yun yung kailangan natin na analysis before we design our dams. Just like structural theory, before tayo mag-design kasi ng structural members of our building, kailangan natin ng analysis or structural analysis. So, we are solving the forces, stresses, na lahat na dadalhin ng our structure. So, itong dam din, dapat alamin din natin yung dadalhin niyang forces, stresses na magagamit natin in designing our structure. So basically, reinforced concrete design yung mga design natin sa dams. Kasi syempre, para maiwasan natin yung mga rust, hindi pwede siyang steel design. Mga ganun. So in designing of pipes then, dapat alam din natin yung behavior of our liquids or fluids in our pipes when they are flowing. Before tayo mag-design kasi ng pipes, alam dapat natin kung anong binibigay na pressure of our fluids. Kasi sila yung dadaan dito sa loob. Ibig sabihin, dapat meron din tayong alam sa steel design or strength of materials. Kasi paano natin malalaman kung ano bang tamang diameter or tamang material na gagamitin natin of our pipes kung hindi natin alam yung stresses na ibibigay ng dadaan dito. Kaya meron tayong fluid mechanics. So, this is the common liquid properties. So, meron tayong 11. Ito lang yung mga common. So, number 1, we have the characteristics of fluid. Types of fluids, fluid pressure and vacuum, density, specific gravity, specific weight, viscosity, kinematic viscosity, vapor pressure, surface tension, and capillary action. So for this presentation, uunahin ko muna yung first 6 or itong 6 na naka-highlight. So ito muna ang pag-uusapan natin for this presentation kasi this is the first part of our introduction. So, meron tayong second part. So abangan nyo lang yung susunod na presentation ko. So first, pag-usapan muna natin yung characteristics of a fluid. So first characteristic of a fluid, it is compressible or meron tayong compressibility. Liquids are only slightly compressible and are assumed to be incompressible for most purposes. And gases are highly compressible. Ibig sabihin, dito sa fluid mechanics o sa hydraulics, usually, ina-assume natin yung liquids natin na incompressible. For example, meron tayong liquid and gas in a container and nag-apply tayo ng weight dito sa ibabaw ng fluid. So, this is the liquid and this is the gas. So, with same pressure P, or itong pressure na binigay ko is the weight. For example, meron tayong weight of this material na nakapatong sa water and meron din sa gas. And meron tayong same area. If this a cylinder na container, meron tayong circular na cross-sectional area. And our force, equivalent yan sa force per area. Or, sa fluid mechanics, usually ginagamit natin na formula for our pressure is gamma H. So mamaya, ipapaliwanag ko ano ba ang ibig sabihin yan. Ano bang ibig sabihin itong gamma na to or symbol na to, and ano ba yung H natin. So, ang behavior ng liquid when subjected to a pressure, the volume is the same. Hindi babago yung volume. Ibig sabihin, yung liquid natin is incompressible. And the density naman is the same. Kasi syempre, hindi babago yung volume and yung mass natin is constant. And we all know the formula for our density na equal yan sa mass over volume. Kung hindi nagbago yung volume, hindi din nagbago yung mass, syempre, yung density natin is the same. So, pag gas naman yung fluid, guys, ganito din yung behavior niya. The volume decreases, as you can see in the figure, and syempre, the density will increase. Kasi pag babalikin natin yung formula for our density, pag lumiit yung value ng volume, syempre, mas lalaki yung value ng density natin. Kasi lilit ang yung denominator, syempre, lalaki yung value ng density nga. So, that is the behavior of our fluids. Ibig sabihin, yung compressible lang na for the subject, dapat yung assume lang natin is gases. Pero usually, simula ngayon hanggang sa katapusan ng SEM natin, more on liquids tayo. Kasi yung gases, usually, inaaral yan sa thermodynamics. Pero for dito sa hydraulics or sa fluid mechanics, usually yung gagamitin natin is liquids na fluid. Another characteristic of a fluid, meron tayong shear resistance. Liquids and gases cannot support shear, and they deform continuously to minimize applied shear forces. So, for example, meron tayong pipe, and meron tayong nag-flow na fluid. So, this is the direction of the flow. So, as you can see, the behavior of fluid ganito. This is the flow niya. So, meron tayong parabolic na part, and ito yung behavior ng fluid when flowing in a pipe. Kasi hindi talaga yung papantay, kasi because meron tayong pwedeng shear. Meron tayong shear force due to friction. And hindi naman talaga smooth talaga yung pipes natin inside. So, meron dyang rough na part. And, syempre, if there are na rough na area, ibig sabihin, meron tayong friction yan. Hindi kaya ng liquids or gas natin na mag-resist ng shear. So, kaya medyo merong part na fluid na nahuhuli, ay merong nauuna. Another characteristic of a fluid, meron tayong shape and volume. So, liquid and gases take on the shapes of their containers. Kahit anong containers dito. Liquids have fixed volumes regardless of their containers, and these volumes are not significantly affected by temperature and pressure. So, for example, meron tayong ganitong container, yung volumes natin hindi magbabago. And kahit uminit pa yan, magbagong temperature, yung volume niya is the same, and even sa pressure. Just like kanina sa manaw ng slides, kahit mag-apply tayo ng pressure in our liquid, hindi babago yung volume niya and density. However, gases take on the volumes of their containers and their densities changes as temperature and pressure changes. So, just like this figure. Kahit same material, same container, pero pag gas yung fluid natin nilagay, ma-occupy lahat nila yung space in our containers. Another characteristics of a fluid, meron tayong tinatawag na pressure. The pressure at a point in a fluid is the same in all directions. the pressure by a fluid on a solid surface, for example, a container wall, is always normal to that surface. Ibig sabihin ng normal, just like in our strength of materials, that is perpendicular to the surface. So for example, meron akong kukunin na particle dito sa liquid in our container. So for example, itong bilog na to, in-exaggerate ko lang. For example, that is a particle in our liquid. And this is applied by pressure and lahat yan equilibrium. So that is in equilibrium. Kasi for example, meron tayong pressure na direction papunta dito. Dapat may equal and opposite yan na reaction, which is na ganito nga. Kung may pa-right, may pa-left dapat. And kung may downward, dapat may opposite din siya na upward. So, yun yung ibig sabihin ng pressure is the same in all directions. And nakalocate yan at value of H, or ibig sabihin ng H, that is the height from the water surface. And yung pressure natin, just like sabi ko kanina, equivalent yan sa force over area or gamma H. Ano ba ibig sabihin ng gamma? Gamma is the unit weight of our liquid. And the H is the height kung saan natin kinukuha yung pressure natin. Pero wala pa tayong idea kung ano bang ibig sabihin ng unit weight. So mamaya ipapaliwanag ko yan sa mga susunod na slides. Pero ngayon, as you can see in the figure, if our particle kinuha natin sa pinakagilid or dikit sa wall in our container, as you can see, meron tayong unbalanced force na kasi walang magre-resist dito na pressure na direction to the right. So, meron tayong unbalanced pressure na ito na mismo yung kukunin natin na pressure. Pag kinuha natin lahat ng particles dito na nakadikit dito sa wall, meron yung equivalent na force or pressure. Ibig sabihin, yung summation nun or yung equivalent pressure diagram nun, meron tayong makukuhang hydrostatic pressure. And kinukuha natin yun na hydrostatic pressure to design our walls or our dams. Kasi itong wall, i-design natin yan dahil sa doon na nag-act sa kanyang force, which is the hydrostatic pressure nga. And dapat hindi mag-fail yung material natin. Just like in designing our dams, dapat alam natin yung unbalanced force na yon na kahit anong mangyari, hindi dapat mag-overflow or masisira yung dam natin. Ganyan yung explanation nun kung bakit nagkakaroon tayo ng unbalanced force. Kasi yung particle natin doon, hindi na siya equilibrium. So may part na unbalanced force na. And even sa bottom, meron tayong dito, as you can see, particle, sa pinaka-bottom na particle, ito naman yung unbalanced force na downward. Kasi walang magre-resist, kundi yung material lang. So dapat, kahit anong mangyari, kahit gano'ng kabigat yung dadalhin ng material, itong material na bottom na container, dapat hindi din na mag-fail. Kahit anong ilagay natin na fluid or anything. Pero kung babalikan natin kanina mga unang slides, pag nasa gitna tayo at any point dito, ano siya, equilibrium or same yung pressure in all directions. Another property of fluid, meron tayong types of fluids. So yung fluid natin is divided into two. So meron tayong ideal fluid and real fluids. So usually, yung ginagamit natin is ideal fluids nga. Meron tayong mga assumptions dito na para nga mapadali yung calculations natin sa subject. And yung real fluids naman natin, meron tayong Newtonian and non-Newtonian. Usually, hindi natin to tinatakal dito sa subject. So more on ideal fluid tayo kasi para nga mapadali yung calculations natin. So yung ideal fluid are assumed to have no viscosity or no resistance to shear. Ina-assume din natin dito na incompressible, ibig sabihin hindi nakakompress, and have uniform velocity distributions when flowing. So that is ideal fluid. So baka may magtanong sa inyo, ano bang ibig sabihin ng viscosity? So sa next part of our introduction, didiscuss ko to. Pero for this presentation, magbibigay lang ako ng konting idea kung ano bang ibig sabihin ng viscosity. Ang ibig sabihin ng viscosity, ito yung stickiness of our fluid. For example, plasma or gelatin, mga parang ganun. Yung parang sticky na liquid or fluid, parang viscous yun. So yun yung viscosity na tinatawag. And real fluids naman exhibit finite viscosities and non-uniform velocity distributions, and it is also compressible. So, ito yung mahirap na part kung magko-consider tayo ng real fluids. And real fluids are divided into two, the Newtonian and non-Newtonian fluids, and nakadepende lang yan on their viscous behavior. So, hindi natin masyado yan pag-usapan dito sa subject. So, more on ideal tayo. Next property of a fluid, dapat alam din natin yung ibig sabihin ng density, especially sa mga constants natin for water, for our fluids na ginagamit natin for this subject. So, the density or yung symbol niya is rho, or itong symbol na yan, that is rho. The density of a fluid is its mass per unit volume. So, ganun nga. So, yung formula niya is m/v. Yung unit niya for SI units is in kilogram per cubic meter. But for English units, naka-slug yan per cubic feet, naka-pound mass per cubic feet. So itong density, simula ngayon hanggang magtapos yung semester natin, gamit natin itong property of our fluid. Meron din tayong approximate densities of common fluids na ginagamit natin especially dito sa subject. So meron tayong table dito, and meron tayong fluids na water, seawater, oil, and mercury. So ito yung apat na to ang usually ginagamit natin dito sa subject. And given yung mga densities nila na naka-pound mass per cubic feet or kilogram per cubic meter. So usually ito yung sinasaulo ko. Tapos convert na lang para maging pound mass per cubic foot. So yung for water, meron tayong 1,000 kg per cubic meter. And for seawater, meron tayong 1,030. For oil, 800. And for mercury, meron tayong 13,600. So ulitin ko lang, this is approximate, hindi yan accurate. So yun yung mga ginagamit natin na approximate values for our densities of some fluids. So dapat tatandaan nyo yan. Another property of our fluid, meron tayong tinatawag na specific gravity. So, yung specific gravity or yung designation niya is SG or yung GS. It is a dimensionless ratio of the fluid's density to some standard reference density. And for liquids and solids, the reference is the density of pure water. So, SG nga for liquid, meron tayong density of the liquid or of the fluid all over the density of water, which is the 1,000 kg per cubic meter nga. Para malaman natin yung specific gravity of that liquid. But for gas naman, syempre, yung reference naman natin, hindi na yung water. So for gas, equivalent din yan sa density of the gas all over the density of air. So yung reference this time is the density of air. And the density of air, equivalent yan sa 1.20 kg per cubic meter. So dapat tatandaan nyo yan. And that is approximate lang, hindi yan eksakto talaga. And meron din tayong another property of our fluid, meron tayong tinatawag na specific weight or tinatawag ko kanina na unit weight. So yung specific weight or unit weight, yung symbol niya is gamma. It is the weight of the fluid per unit volume. Ibig sabihin, yung unit niya dapat naka-Newton or pound force per volume. So yung formula naman for our specific weight or unit weight of our fluid, equivalent yan sa the density of the fluid times G. Ano bang ibig sabihin ng G? So yung G natin, that is this acceleration due to gravity, na for metric unit, meron tayong 9.81 meter per second square. But for English unit naman, yung value ng acceleration due to gravity, that is 32.2 feet per second square. So lahat ng values na yan dapat tatandaan nyo, especially sa exam, kasi may mga times na hindi talaga yan given. And our unit for our specific weight, for metric unit, that is kilonewton per cubic meter, and for English unit, that is pound force per cubic foot. Another property of our fluid, may tayong fluid pressure and vacuum. So, itong topic na to, gagawin ko pa yan ng another video sa next presentation ko para makapagbigay tayo ng maraming examples dito. So, this is the last part of our presentation dito, and magbibigay ako ng konting introduction of this part. So, yung pressure natin, equivalent yan nga sa gamma H, and yung unit niya is kilonewton per square meter, or pascal, or kilopascal, or megapascal. Kasi ginagamit natin yung kilopascal and megapascal para mapaliit yung value. Kasi pag pascal yung ginagamit natin lagi, baka magbigay ng pressure na malalaki. Para kumonte yung value niya, gumagamit tayo ng kilopascal or megapascal. Fluid pressures are measured with respect to two pressure references. So, meron tayong zero pressure and atmospheric pressure. So, ito yung mga reference natin when solving the pressure in our fluids. So, pressures measured with respect to a true zero pressure reference are known as absolute pressure. And the pressure naman measured with respect to atmospheric pressure are known as gauge pressures. So, to distinguish between these two pressure measurements, the letter A and G are traditionally added to the unit symbols in the English unit system. For example, 14.7 PSIA. Ibig sabihin yan, pounds per square inch absolute. Kasi yung A nga, ang ibig sabihin yan, that is absolute. And for G naman, that is gauge pressure. And for SI units naman, yung actual word talaga yung dinadagdag natin. For example, yung measurement na kilopascal, kasi yung kilopascal, that is a metric unit or SI unit, instead na A yung idadagdag natin, dapat yung word na lang na absolute. For example, kilopascal absolute. Ganon. For simplicity, mayroon tayong formula na yung pressure natin for absolute, equivalent lang yan sa the gauge pressure plus atmospheric pressure. So, para mapaliwanag natin ng mabuti kung ano bang ibig sabihin ng absolute pressure, and gauge, and atmospheric, for example, meron tayong water, and itong figure na to, meron tayong soil, and this is the water, ito nasa loob dito. Itong triangle, ito yung ginagamit ko usually na symbol para ma-indicate na this is the water surface. So, for example, kuha ulit ako ng particle in our water, tapos in-exaggerate ko, na pinalaki ko, na itong circle na yan. So, at distance h yan, so yung pressure niyan is equivalent lang sa yung height of that fluid, of that particle from the water surface, times yung unit weight of the fluid. Kung ano ba yan? Kung water yan, dapat alam mo yung unit weight of the water. So, equivalent lang yan sa 9.81 kilonewton per cubic meter. So, itong pressure na nakuha natin, that is gauge pressure. Kasi yung atmospheric pressure natin, ano yan? Constant yan. So, nakukuha yung atmospheric pressure in the surface of the Earth. For example, tayo dito sa surface of the Earth, meron talaga tayong nararamdaman na pressure. So, ang tawag doon is atmospheric pressure. And equal lang yan sa 14.7 PSIA or 101.325 kilopascal. So, feeling natin kasi wala tayong nararamdaman na pressure, pero since when we are born in this surface talaga sa Earth, meron talaga tayong nararamdaman na pressure. So, ito yung atmospheric pressure ang dahilan kung bakit hindi tayo nag-explode dito sa surface. Pero kung aangat tayo sa surface of the Earth pataas, siyempre, liliit yung pressure natin and dun tayo mag-explode sa taas. So yun. So kung yung reference natin nga is the atmospheric pressure, ibig sabihin, i-set natin na 0 yung atmospheric and yung makukuha lang natin is gauge pressure. Pero kung ang reference natin is the 0 pressure, dapat mag-add tayo ng atmospheric. So yung makukuha natin na pinaka-pressure talaga dito sa particle na to in our water, kung yung reference natin is 0 pressure, yung makukuha natin dapat is absolute. Ibig sabihin, yung gauge pressure natin dapat mag-add nga tayo ng atmospheric. So usually dito sa subject natin or dito sa fluid mechanics, pag hindi ako nag-indicate ng kung gauge or absolute, usually gauge yung pinapahanap ko. So next, pag-usapan din natin yung vacuum. So yung vacuum measurement is implicitly a pressure below atmospheric. So ito yung negative gauge pressure. For example, kung umangat tayo sa water surface or sa earth surface, syempre magbabawas tayo ng pressure and magle-less than yan sa atmospheric. Ibig sabihin, that is negative gauge pressure. Pero kung pupunta tayo pababa, yung gauge pressure naman natin magdagdagdag. Kaya yung designation dito is positive. Ibig sabihin, pag downward, that is positive gauge pressure. So yung vacuum lang yung pataas or pag nag-less than yung pressure natin sa atmospheric pressure. So that's it. Thank you very much, guys. So kung meron kayong questions, just comment below or just PM me sa Facebook. And magbibigay pa ako ng another examples sa fluid pressure for our next presentation dito sa YouTube para marami tayong examples. Ganun. And have a good day.